Welcome to 4.5, the pulley. Today we're going to be talking about the theory of the pulley. So what's a pulley? It's a system that consists of a wheel used to transmit power by means of a band, belt, cord, rope, or chain passing over its rim. They are used mainly for traction or elevation of heavy objects. Here we can see an example of a pulley. Now there are types of pulleys. One is the fixed pulley, a mobile pulley, or mobile pulley, also a pulley system. As you can see, the fixed pulley consists of one load, a fulcrum, and you pull the cord or chain that is pulling the load. So you can see one load that you're pulling. In this case, the mechanical advantage of the fixed pulley is 1. A mobile pulley usually is fixed to the ceiling, and a pulley is fixed to an object. And when you pull the cord or the string or the chain, the object rises up. The mechanical advantage of a mobile pulley is 2. If you make a horizontal line crossing the pulley system, the mobile pulley, you can find that you can cross over 2 cords or 2 lines. Usually it is related to the mechanical advantage. In the case of the pulley system, the mechanical advantage of a pulley system is equal to the number of sections of the rope pulling up on the object. Same case as before we mentioned. If you cross a line on the horizontal way, you find 1, 2, and 3 lines you're going to cross. So the mechanical advantage of this is 3. Let's talk about the fixed pulley. A fixed pulley is a wheel attached to a surface. It changes the direction of the applied force. You pull it downwards and the load goes upwards, okay? And the mechanical advantage, because it has the same amount of force is required to pull the load. So you pull one load, you get to lift one load. One way to explain a fixed pulley is that the resistance arm and the effort arm are both the same radius. As you can see, they are equal, so there's no mechanical advantage. You can see the radius of the pulley, the same radius of the arm. So we're talking about the same thing. So in this case, there is no mechanical advantage, or it's going to be equal to 1. As an example, I'm showing you 100 pounds that are being pulled up by a pulley. In this case, provides a change of motion, but no mechanical advantage, as we mentioned before. Also, the distance traveled by the object to the right is the same as the rope traveled by tension, which means if the object travels 100 feet, it's the same 100 feet you need to pull the cord or the line to get this object to rise. Here's a way to calculate the ideal mechanical advantage of fixed pulley. In this case, we have the radius R, capital R, over R, which is the same thing. In this case, the mechanical advantage is 1. Now let's talk about the mobile pulley. You can see the image, pulley moves along the rope. The wheel supports load. The effort is in the same direction as movement. So you pull up, the object goes up. And also reduces the forces needed to move an object, reduces a lot the force. A movable pulley is a second-class pulley. The effort arm is the diameter and the resistance arm is the radius. So that's why the explanation of this becomes this. As an example, we're trying to provide the change of direction and mechanical advantage 1 to 2 at the expense of having to increase the amount of line to pull. These kinds of diagrams are easier to analyze, by the way, because if you see the load, we have 100 pounds to move. We have fixed point over here on the top. A line goes to the pulley that's attached to the weight. And then this line goes to another pulley. And in this case, you are pulling 50 pounds because it's the same line that you're lifting over here. You're distributing the weight between the line on the left and the line in the middle. So you just need to pull 50 pounds to lift 100 pounds. Real life explanation will be something like this. So where this guy is trying to lift up a 200 pounds barrel. So can you calculate how much effort is this guy doing? Just by seeing it and seeing the example on the top, you can figure out that the force that he's applying to lift out this barrel, 200-pound barrel, will be just 100 pounds, the half of this value on the weight of the barrel. The ideal mechanical advantage of a mobile pulley is calculated by the diameter over the radius. In this case, twice the radius over a radius. So it will give you a mechanical advantage of 2. So what did we learn? We learned what's a pulley, the type of pulleys, the explanation of the type of pulleys, so we can understand which of them are which, and also we gave you some examples of the pulleys. Also, we talked about the mechanical advantage of pulleys. This will help you to the next step. The next video will show you some pulleys problems solved so you can figure out how to work with them. So thanks for watching, and go ahead and take a look on the next video.